Hello students, today we will be talking about magnetism. Magnetism means magnets. Magnets seek magnetism. You must have seen magnets in your home, at school. So where all have you seen magnets? One is on the doors of a closet, in speakers, or in various toys that you must have used. You have handled magnets. First of all, let's go back to the story that is said to be the discovery point of magnets. So, in Greece, there was a place named Magnesia and a shepherd named Magnus. So, being a shepherd, he had lots of goats, sheep. He used to go to graze them. One day, while they were grazing, also Magnus had a long stick and its ends had some iron joint. So once he had gone for tending of his goats, and while returning, he found that there was something odd happening. At a particular place, when he would put his iron ended stick down, it would stick to some stones there, and it seemed really odd. When he used to go forward, that stick would just stick at the back. That is said to be the origin point where people actually understood that there were magnets. Of course, not at that time, because there was a lot of suspicion as to what is this. But later discoveries proved that that was a magnet. The magnet that is found in nature is known as magnetite. Before we jump to the properties, let us know what shapes do magnets have. What shape have you seen a magnet in? When we think of magnets, generally what comes to our mind is a bar magnet having north and south poles. But magnet is not only in bar shape. There is a horseshoe magnet, a U-shaped magnet, a disc magnet, as you can see here. And for our experiments, we are going to use this ring magnet. Let's jump to the properties of magnet. Now, you all know that magnets are used in magnetic compass to seek the direction. They were used by sailors. Why is magnet used in magnetic compass? Have you ever thought? Basically, because magnet shows directive property. That means if you take a magnet, as I have this ring magnet, and if you suspend it to a thread, the magnet will come to rest in north-south direction. So once you know the north-south direction, it's very easy to find the other directions. However, I spin this magnet, it is ultimately going to rest in the north-south direction. So that is the directive property of the magnet. Magnet always exists in two poles. Any magnet will have two poles. All of you know that? The north pole and the south pole, or the north seeking pole and the south seeking pole. So even this magnet has north pole and south pole. Now just think, what if a magnet falls down and breaks? So will that magnet only have one pole now, because it is broken? So basically, this is your magnet. It broke. So here there was north pole, here there was south pole. Now, will this magnet have only north pole and only south pole? So, no. Magnet, however small, in whichever shape, size it falls, it breaks down, it will always have two poles. Two poles will always exist in a magnet. Then, all of you are aware that like poles repel, unlike poles attract. What does that mean? Like poles of a magnet, that means if we have two magnets and if you bring in front, north pole of magnet A and north pole of magnet B, they are going to get repelled. That means pushed away from each other. Similarly, if you bring south pole of magnet A and south pole of magnet B, again they will repel because those are the like poles. Unlike poles attract in the sense if you bring north pole of magnet A in front of south pole of the magnet B, they will attract. So this is how like poles repel and unlike poles attract. Magnets always show attractive property towards ferromagnetic material. If you have a magnet or if you have ever played with a magnet, you will have that sense or that knowledge, and you must have noticed that magnet does not attract to everything. Also, magnet does not attract to every metal. Magnet attracts to iron, nickel or cobalt. So any material to which magnet is attracting should have at least one of these three: iron, nickel or cobalt. So they are known as ferromagnetic material. So this is the attractive property of magnet. So you can test that as well. What is the strength of a magnet? How do you know? If I stand with a magnet here and there is some iron cupboard at the other end, will this magnet get attracted? So no. Every magnet has its own field. That means the area around it in which it is powerful or it shows magnetic properties. That is known as the magnetic field of the magnet. Also, there are magnetic lines of force. That means the lines that go from north pole to the south pole. Those are known as magnetic lines of force. So we are going to do an activity on magnetic lines of force as well. So with this much knowledge about magnets, one more thing I will like to add is magnetism can be induced. That means if I have an, say, iron nail, and if I have a magnet, and if I rub that magnet on the iron nail in a particular direction, the iron nail will turn into a magnet. So it is said that magnetism can be induced. We can also make a magnet with the help of electricity, and that is known as an electromagnet. So electromagnets are more in use than permanent magnets. Have you ever heard, now where is this, all these magnetism, okay, they are used in your home appliances, they are used in your toys, but are they really used anywhere else? So yes, magnets are nowadays used in maglev trains, magnetic levitating trains. So today we are going to make a magnetic levitating pencil. We are actually going to make the pencil float in air with the help of magnetism. So also there have been researches wherein scientists from foreign countries have tried to levitate a frog with magnetic ambience around it. So if ever this happens, would you like to fly with magnets? I guess yes. So let's get going for the activities. So students, let's start with the activities. I hope you stick like a magnet throughout. So let's start. First activity will be seeing attraction and repulsion in magnets. Take the straw and keep it upright. Pass one magnet through it and pass the other magnet. Now you can see both these magnets have attracted to each other, they are stuck to each other. That means north and south poles, north pole of this magnet and south pole of this magnet, or north pole of this magnet and south pole of the other magnet, are in front of each other. That means unlike poles attract. That is why these magnets are showing attraction right now. So let us see if they repel. So what you have to do is keep the lower magnet as it is, take the upper magnet and just flip it and pass it through the straw. Now can you see both these magnets are repelling? I'll show you like this. How much ever you try, they get pushed away. So this is repulsive property. That means like poles of these two magnets are facing each other now. So repulsive property. One more way of repulsive property, one more way in which, see, this is a following magnet. So you can make some path, curved path, and ask your friends to make this magnet follow that path with the other magnet. You can design this game for yourself. As in, there is some path like this. Ask your friend to follow, make this magnet follow the other magnet. Okay? So, this is the first activity. Now let's see how induced magnetism works. That means I am going to take this magnet, attract one pin to it and see if the pin that is attached to the magnet now turns into a magnet. So yes, see, the pin has turned into a magnet because the second pin is attracted to the pin attached to the magnet. It is not attached directly to the magnet that I have. Now let's see how strong this bond is. Yeah, see, third magnet is also getting attached. So this is how these pins have turned into magnets. See, you can take safety pins and try this out even further to see till which pin the magnetism actually is strong enough, that has got induced. Now, since we're talking of induced magnetism, let's start by making let's make a magnetic compass. For this I need the needle and this magnet. Start rubbing the magnet over the needle in one direction. You have to do it for say 100 times at least. Do not rub the magnet in this fashion. This needle will turn into a magnet only when the magnet in your hand is rubbed in one particular direction. So it could be this direction or this direction, but one direction. So I'm rubbing it in the direction that I'm showing. So let's rub it for say 100 times. Now I have rubbed this needle by magnet. Let's see if it has turned into a magnet before we see it. Oh, it has turned into a magnet. Look at this. It is attracting a pin. So first see whether it is attracting a pin like this. Now you can say that the magnetism is induced in the needle. Release paper from this pink sheet that you can see and stick the magnet on it. Take a bowl of water and release this pin into the water. See, you can see the pin is resting in the north-south direction. If you have an actual compass at home, you can find out whether this pin is actually showing the north-south direction. So this is the north-south direction. Now let us see how magnetic lines of force are created in the magnet. These magnetic lines of force of the magnet using iron filings. In this small container you have iron filings. Transfer these iron filings onto some paper. Keep them aside. This ring magnet has its poles like this. So one pole here and one pole here. Okay? They are not like this. One pole here and one pole here. So for making this magnetic lines of force experiment work, I have to keep this magnet standing. Place a card on top of it. Okay. Take some iron filing powder and gently put it on the card. Not too much. And tap the card a little bit at one corner. Gently tap it. You can see a pattern has formed. This pattern, these are magnetic lines of force. You can see the pattern. Also make sure that do not take this container and start pouring the iron filings like this. You have to follow this method for proper magnetic lines of force structure to be formed. See, the magnet has attracted to the iron filings. The first step in making of magnetic levitating pencil, you will observe that you've been given a pencil with two magnets already inserted into them. So you have to be very careful. These two magnets should not be mixed with the other magnets in the kit, because the holes of the magnets, these ring magnets, differ. That is the reason these two magnets are already inserted in the pencil. If you mix them, it will be little difficult for you to see which magnets actually go into the pencil. You can see there are O-type rings. So these are for packing the magnets into the pencil. Pass this O-ring into the pencil. Now you have seen that I have sharpened the pencil, pointed it is. So sharpen it that well. Inserted the O-ring into the pencil. Then insert the magnet. Again insert another O-ring. Be careful with the point of the pencil. So this is one assembly. Another is near the point. Same, passing of O-ring, then passing of magnet, and then again passing the O-ring. Okay, so this is ready. You've been given a foam like this. One side of the foam has slits. If you slightly turn it into a circular fashion, the foam, you will be able to see the slits. So one of these slits is very short. In the shorter slit, you have to pass this acrylic piece. While passing, make sure that you slightly turn the foam, not too much, and pass the slit. Now what you have to remember is this acrylic piece has 3 hole-like structures, but these are not holes, these are just depressions like holes. So the deep part of the depression has to face towards this foam. See, I can put my pencil. You can see that the pencil goes into this depression. Okay, so it has to be like this. This pencil is ready. The acrylic piece we have fitted. Now we have to fix these 4 magnets into the foam, but there is an arrangement to it. The rare magnet is for repulsion, and these magnets are to be put in the last slit. So what is an easy way to do it is keep the magnet in attraction with the rare magnet of the pencil, bring it down till the slit, and just turn the magnet this way and put it. While putting the magnet, make sure that you slightly turn the foam in a circular fashion, not too much. Again, pencil, magnet in attraction, but it has to be in repulsion. So bring it down till the slit, turn it, and now fix it. So let's see if they are in repulsion. Yes, they are in repulsion. Okay, so done. The front magnet has to be in attraction with the magnets in the second slit. So what you have to do is take the take the pencil, magnet in attraction, but really you don't have to do anything. Just bring the pencil down here, take the magnet as it is put in the second slit. So while putting it, slightly turn the foam. Again, this magnet, bring it down here, slightly turn the foam. It is. So let us see if this is an attraction. So yes, this is in repulsion. Now one important step, take the sun board that has been given to you, remove the release paper from the double side tape, slightly turn this foam in other direction, not too much, and fix the foam on top of the sheet. So you have to fix it edge to edge, so like this. Okay, so you have to make it straight. So this is straight now. Okay, there should be no bulge. So if you find a bulge, just slightly press on it and turn in the other direction. Okay, now let's see if our pencil levitates. So no, this magnet has to come on top of the rare magnets. So it's far away, we'll bring it in front. still quite far. This magnet near the point has to be a little behind these two magnets that are in attraction. After the adjustment, rest the point of the pencil in the second hole and see the pencil is levitating. Let me lift it up and show. Look at this. Can you see the pencil is levitating? It is not resting on anything. Okay. Just to add some more fun, we will attach this propeller to the pencil from behind. So for that, we need to sharpen the rear end a little bit, not turn it into some pointed part, just little bit. So you have to keep checking while you are, does this fit? No. So a little bit more I need to sharpen. Does not have to be loose. Okay. Again, let's see. Let me keep it on something so that I can show it to you. Okay. What you can do is blow from this side, from the propeller side, and see how the pencil rolls or rotates around itself. You can keep this in your window. You can see that the pencil will keep going around itself, and because of magnetic levitation it will also float. So let me blow and see if this pencil goes round. So you'll have to blow from a little distance. So enjoy with your levitating pencil.